Hi, my name is Patrick Desjardins. In this episode, you will learn about the implicit declaration, which allows having a strongly typed code without having to explicitly give a type. The inference is the mechanism that TypeScript employs to discover a variable's type without having you, the developer, specifying the type. The principle of inference is to reduce the typing of code. On the other side, the disadvantage is that the code can be harder to understand. The reason is that you need to resolve the path until you find the type. Thus, having the right balance between explicit and implicit is an art to develop. How does inference looks? Let's dive into an example of assigning a variable with the declarator let and the value 1 without specifying the type. We both know that the value is a number. TypeScript can also guess. The verb for TypeScript's finding the type is inferring. TypeScript infers the value because we assign that value to 1 to a variable without specifying the type. The correspondence of the infer type is a code that specifies a variable x with a colon and a mention to number. This time, it would not be inferred, but an explicit type. In that particular case, the visibility of the type is a clear event without the type because the number 1 is right next to the assignation and not hidden by a function or another variable or a parameter or buried into an object. Before jumping into the second example, the declarator was let by purpose to have the inference to a number. If the declarator is const, the inference detects that the value cannot change and infer the type to be the number 1 instead of number. The second example assigns the variable x from a function. The function is declared in a single line with declare, which means that the body of the function is defined elsewhere. For this example, let's imagine the function exists. For the purpose of learning inference, the importance is that the function returns a string as mentioned at the end of the function's signature. TypeScript understands the contract of the function and it assigns to the variable x the type string. The reason is that TypeScript knows that the function cannot return anything else than a string. In that case, implicit is a shortcut that comes at the expense that the variable x is harder to determine with a quick glimpse. Thus, not marking type only when implicit typing makes your code not harder to understand for you and also for other people. Inference also works with scenarios that are less straightforward than the two previous examples we explained so far. For example, a function's body with several returns that do not have an explicit return type. A quick recall of the signature of a function ends with a return type. If absent, TypeScript infer the function's return type. For example, the function presented has multiple return statements. The function returns depending on the input. If the parameter is 1, then a string is returned. However, if the parameter is 2, then a collection is returned. If 3, a boolean is returned. And if something else, nothing is returned, meaning that undefined is returned. Hence, the inference type is the union of number, 1 as string, a list of number, true and undefined. The topic of inference will continue toward the progression of this course. We will see inference once we touch generic to create code that can be reused without carrying the burden of type, but to remain strictly typed. We will also talk about inference when we will discuss the narrowing unions type. Finally, we will see the infer when we will dive into creating dynamic type with the keyword infer. So stay tuned for more inference. So here we are again. We are at a fork where you need to make a decision. Would you like to learn about the Boolean type or about the string type? Regardless of your choice, it is the good one because it is your choice. Do not forget to like this video and subscribe. See you soon.